je to treba vžgati? Dragi kolegi, dragi študenti, preden se posvetimo današnjemu predavanju, se spomnimo izrednega člana akademije, profesorja Mihe Brenčiča, ki nas je prejšnji teden mnogo prezgodaj zavedno zapustil. Počastimo njegov spomin z minuto molka. Naj počiva v miru. Žalna seja bo v ponedeljek ob 11. v tej dvorani. Vlasta, prosim. Zdaj bo pa jaz Vlasto predstavila brez mikrofona, mislim, da se bo slišati. In sicer v slovenščini Vlasta razume slovensko normalno. Današnja predavateljica, profesorica Vlaste Ćosović, je geologinja, zaslužna profesorica na Prirodoslovno-matematični fakulteti v Zagrebu in izredna članica Hrvaške akademije znanosti in umetnosti. Na Univerzi v Zagrebu je bila nosilka več paleontoloških predmetov na dodiplomskem in podiplomskem študiju. Kot gostujoča profesorica je predavala na univerzah v Ljubljani, vi ste premladi, da se tega spomnite, Krakovu in na Dunaju. Trenutno vodi specializirane predmete na doktorskem študiju Univerze v Zagrebu in predava na dodiplomskem študiju Znanost v morju na Univerzi v Pulju. Osrednja tema njenih raziskav so fosilne in recentne bentoške foraminifere. Na podlagi foraminifer, drugih spremljajočih fosilov in facijesne analize je za sedimentarno evolucijo paleogenskih plasti zunanjih dinaridov izdelala model, ki se je uveljavil kot referenčni model za predgorne sisteme na širšem perimediteranskem območju. Enako zavzeto se posveča tudi študiju recentnih foraminifer, Jadranskega morja v povezavi z naravnimi in antropogenimi vplivi na okolje. In o vsem tem nam bo danes predavala. Že od začetka kariere zelo intenzivno sodeluje z geologi iz Slovenije, kar se kaže predvsem v številnih skupnih objavah. Najdaljše in tudi najbolj plodno je sodelovanje z našo Katico Drobne, ki je bila na začetku predvsem svetovalka in mentorica, skupaj pa delata še danes. Mimogrede, dr. Katica Drobne je predvčerajšnjem praznovala 90 let in je še vedno polna raziskovalnega zanosa.
Stare stvari v novi obliki predstavljati.
Hvala,
če se kdo upa, javite. Pravi velja.
Profesorica Vlaste Ćosović je bila junija lani izvoljena za dopisno članico 4. razreda SAZU in nam bo sedaj v nastopnem predavanju predstavila svoje delo. Prosim, Vlasta.
Good morning to everyone. I'm going to speak in English because I spent a lot of days and months here in Ljubljana, but I was never forced to speak Slovenian language, and that's happened that today I can understand you more or less, not everything, but I am unable to speak, especially not properly. So this presentation is going to be in English. First of all, I would like to thank you because you are here today, and I feel in one way honored to stand before you today because it is my inauguration talk and it is something very, very important in my life. In life, everybody who is doing science. So thank you again for being here. And I am grateful to be joining the Slovenian Academy of Science and Arts. So what I'm going to speak today is in some way a very short description what I have been doing for the years. So whatever I was doing, it was always connected with the foraminifera, benthic foraminifera. And today, I'm going to try to show a connection between the benthic foraminifera from, it is always the problem when you start lecturing how it works. So does it work? No. Okay, switch on. Put here. No. Okay, without it. So to show how the benthic foraminifera deal with the recent sedimentary environment, it means from the Adriatic Sea. And the other side, I shall show you how you can use it to reconstruct something from the past, something from the Eocene sediments, and where I shall be, in the Dinaric area, because I'm coming from the Dinaric part. And here also, great portion of Dinarids are present. Okay. So how my presentation is organized? In 4 steps, I would dare to say. So the first, I'm going to give you very, very short description about the foraminifera. I'm not going to speak about their systematics. I'm not going to speak about their physiology. But I should just try to okay. I am going just to try to stay with this timekeepers information, how they keep information from the past. So that it's going to be just general information about the foraminifera. Then I shall move to Dinarids. I shall stay in the Croatian part of Dinarids, I have to say, and I'm going to be from the northwestern part, Istria, up to the southeastern part, to Dalmatia. What I'm going to speak, not how the Dinarids are about their origin, how they are made of, but I shall just give you a short glimpse about the Eocene sediments that crop out along the eastern coast. And I shall try to describe why we do have so many differentiation within these Eocene sediments. And then I shall try to connect it with the tectonical situation, because Eocene or Paleogene time here are very, very dynamic time in tectonical sense. And then I shall try to describe what is going on, but also be aware that when we are speaking about Dinarids, we are speaking about the limestones, about the carbonates. And the production of carbonates depends on organisms, because they contributed a lot to them. So the distribution of organism is related with the climatic situation, with climates. And Eocene is a period, or the whole Paleogene, which is very important for us today. It was time when we already started to have climate close to today. Okay, it was warmer than today. But what we can recorded in the Eocene or Paleogene is that we had several warming episodes. And I'm going to show you how you can detect these warming episodes on the sediments that were originated in the sea which is similar to the sea we have now, Adriatic Sea. So that is the point of the second step. Then I shall move further on to show you something about the recent foraminifera in Adriatic. I pick up just 2 sites where we did research, or where we collected the material. And if you are looking at this nice foraminifera in this color, be aware that it is artificial. Not artificial just to provoke your interest to my presentation, but it is results of doing some preparation of material in order to find out about the foraminifera. So this is how to say procedure coloring of them, and they can get this very nice color. And finally, I should make something which is not a conclusion, because there is no conclusion in a kind of presentation when we do have some survey of my work. So I shall just give you some glimpse of what you can, if you are working with foraminifera, how you can use them, and even what maybe I plan to do a little bit in the future. So that is 4 steps which we are going to pass today. And now I should start with the beginning. First, about foraminifera. So what we call generally, when even you do the Googling and find out about the foraminifera, immediately you will find out that they are unicellular organisms, and I'm sure that you are informed about them. We know that there are so many species of foraminifera, around 50,000 species. 40,000 belong to the fossil material. Only 10,000 are recent. And that is another thing which is very important, and that is that foraminifera live in the water. When I was a student, I learned that all foraminifera are or were marine habitats, living in the sea, no matter if it is saline, normal marine, or if we are speaking about brackish. But today we know that they live even in the fresh water. And there are 23 species of freshwater foraminifera. So why they are important for us? They are very small. Okay, again, there are some of them which are very, very large, even up to the 15 centimeter in diameter, but generally they are small. But they contain something which is very important. They have skeleton. We called it test, although you can refer also as a shell. So they contain skeleton. Skeleton is made of minerals, mostly calcareous minerals or calcite or aragonite. So when they are making their shell, when they are making their skeleton, they do it in accordance with the condition in environment. So in one way, you have a skeleton which is in balance with the ecological condition in the water where foraminifera are living. So they have to, if it is in balance, they have to register what is the temperature of the water, oxygenation of the water, as well as pH or other contamination or adhesive. So that is like archive. So they put inside their shell all this information. And you can look at the foraminifera like black boxes in an airplane, because they are going to register everything what was going on during their life. And life is very short when we are dealing with foraminifera. It is just between 2 weeks up to the several seasons. When I say several seasons, it means up to 2 years. So in this short time period, they are going to register changes. How? Because when they are making their shell all the life, they are not like a vertebrate organism like we, that are making our skeleton only up to the young ages, up to 25 years old. They are doing all life. So whenever changes occur, they are going to increase their skeleton, and what is going on during this period is going to be recorded in their test. That is important. And what else I have to say? That we do have another kind of foraminifera, I have to be honest, which do not possess the mineral skeleton. It is organic, and for this presentation they are out of my focus and I'm not going to refer to them. And that is another thing. With foraminifera it's very easy to deal because their shape is very specific, and it is very, very difficult to make mistake when you have a material fossil to say, oh, this is foraminifera or this is something else. It is very, very easy to recognize them because of their specific shape and the fact that they are made of several steps in growing phase, made of chamber, which they added, and there is of specific form, and it is just something unique. And to finish with this slide, which is already a little bit too long in front of you, I have to say 2 main points. One main point is reticulopodia, which is here put as a characteristic of foraminifera. Whole life, whatever they are doing, feeding, resting, moving, or even reproduction, they depend on reticulopodia. Reticulopodia, in fact, is a part of cytoplasm that just protrude out of the cell and is out of the skeleton. And it is a very important part of them, because with the reticulopodia, they are able to enlarge their skeleton, so it means for the growth, as well as for the reproduction, feeding, breeding, and everything what is for their life. And finally, how they look like. Their shape, I said, depends on the growth strategy about how they added the chambers, but it is also the result of reproduction. Foraminifera do have 2 generations, so you can find what we call A and B generation of foraminifera, and it is interesting thing and interesting point that usually the representative, the specimen, which was produced by copying of gametes, do not look like the specimen which was produced during the division of the cell, or what we call something like cloning. So they do have this generation differentiation, and even we know that there is another, the third generation. But it is, and this is how foraminifera look like during their life. So you can see this reticulopodia just extruding outside, and you can see this in white, this skeleton shell or test which is made. So what is also interesting that where they do live, I said in water, but they can inhabit the sea bottom, and then we call them benthic, or they can float within the water column, and then we call them planktonic. And you can easily distinguish between the planktonic and benthic foraminifera, because planktonic foraminifera have to float, so they have to make their shell that allow them to float. And that means that they must be like a cube or a bubble or something which is isometric. While benthic foraminifera lie on the sea bottom, and they are just adopted to the configuration of the sea bottom. When I say sea bottom, doesn't mean that it must be sediment on the sea bottom. You can use even some algae or the seaweeds or something else. And then among the benthic foraminifera, there is another differentiation, because we can recognize two types of benthic foraminifera, one which we call smaller benthic and the other large. And they are really differentiated by their sizes. Large are usually greater than 2 millimeters in diameter, and also with some variation in the skeleton, in architecture of their test. So what I'm going to speak today mostly are going to be related with the larger benthic foraminifera. Okay, and then another thing about the foraminifera is why they are present somewhere. Their abundances, their diversity depend a lot of condition in water. So they are going to be present somewhere, or absent from somewhere, or not so many abundant in accordance with the temperature of the water. They depend a lot of them. Then it is about the concentration of the food. We usually call it nutrients. Then they depend on the oxygen, because they have to breathe like all the organisms. Then they are related with even the trace elements which are present in the water. And also their ability also depend, especially when we are speaking about the benthic foraminifera, about the nature characteristic of the sea bottom. So do we have a rocky sea bottom? Do we have sandy, muddy, or we do have some kind of cover, no matter if it is another organism, a heterotroph like lamellibranch, on top of which they can live, or we are dealing with some algae or something else. And when we know this, that their distribution is connected with the ecological condition, then you can be aware that they are sensitive to pollution. And when we are thinking about pollution, and these days, we know that we are suffering of pollution. So we do have the activity, some of them anthropogenic activity, which increase the presence of pollutants in the water, and they are going to react. So that is why we are studying them in a recent sediment. And just to finish about the foraminifera with some peculiarity is that we know them from everyday life. You do not need to study biology or geology to know foraminifera. It is, for instance, that whenever you come to the Giza, you will find a lot of foraminifera just in the blocks of the pyramids. Or what I would dare to say is less known, that the Nobel laureate Wisława Szymborska wrote a poem dedicated to foraminifera. Be aware that she didn't know what you know about foraminifera. She just know about their beauty and fact that they are present even after organism died. So you know, like poets, what they are doing and why they use and how they deal with them. So, and then it is also the last thing that we have to say, that they are very, very important today in this climate, I would dare to say, challenging time, because they are calcifiers. So they are making skeleton of calcite and aragonite. In calcite, when you look at its formula, you have CO2. So when foraminifera died, the calcite is going to deposit on the sea bottom, and with them, the CO2. So think of them like of corals, what you know, that they are very important as a storage, the storage room for the CO2. And it is estimation about the production per year. So when you calculate this billion of tons which are produced and lay on the ocean's bottom, on the sea bottom, that they are just governing quantity of the CO2. And now we shall move to the second part, just before to say that there are some differentiation if you are studying the recent of the fossil foraminifera. It is how you get example. If you are studying recent, you have to go to the sea, have equipment to take the sea bottom sediment. So you do coring or grabbing. If you are in the fossil material, then there is no problem. You are just, all of you already had some field work and know how the sampling is going on. So, and also in laboratory, there are differentiation. In technique you applied, it's depend if you are dealing with sedimentary rock. So you are, in this case, you are going to prepare some thin section and study foraminifera from their section, or you have the sediment, and then you can isolate it, the foraminifera by itself. And now the second part, it's about the dinarids, external dinarids, and the Paleogene time. So what was our main challenge when we are doing? It's to find the proper outcrop or the section. You would dare to say, because I presume that all of you are in one way, how to say, you know very well how the dinarids look like and what is a karst region. And you know that you have the vast area covered with stone that you walk for kilometers on the stone. And you would say, oh, there is no problem to find the proper section because there is just outcrop is lying a kilometer and kilometer in front of me and I can take it. But it is not the way when you are looking in and doing some sedimentological and micropaleontological work. You then find out that to find a proper outcrop is not so easy. You rely on literature, on everything, but nevertheless, it is not easy. So what means the proper section? That means that you can find continuous sedimentation for a certain portion of time. And when we are dealing with dinarids, we do have the following problem. Dinarids are made of Mesozoic sediments, but I am not referring today to these, and of the Paleogene sediments. Paleogene sediments originated in a shallow water environment. In shallow water environment, if the sea level drop or if the sea level increase, the changes will take place. And then your foraminifera, which are very important contributor for the sediments, are going to increase in number or decrease, cease to produce themselves, cease for sedimentation. So that's you have to think, and that's a problem with our sedimentation. Also, we have to be aware that we are speaking with a tectonically very active period. It is part when dinarids are coming out. It is a part when Himalaya you will find is just outfitting. So all around the world we are facing a very, very strong tectonic activity, and it was included in formation of the basin of the place where foraminifera are going to live. And then the third part, as I said you before, Eocene and Paleogene is a climatically very, very interesting period because of this short and little bit longer part of extreme warming. Warming which you are facing last year, for instance, during the summer, and what we predicted that we shall facing this. So short period when the extreme temperature and organism that live 2 weeks, month, are going to react to them. So that is what is about the Paleogene. So I say to you, we are going to be in Istria as a part of our investigation area of Paleogene sediments. Then we shall move to the northern Dalmatian area. This is around Novigrad, and you can say that in hinterland of Zadar, and then further to the south to the Pelješac. And what we are targeting to find the proper outcrop, the outcrop which are going to contain even the sediment with the fossil, and the where we shall be able to do age attribution using the foraminifera, larger foraminifera, as well as planktonic. So that was our transition. But why it is a problem? So I shall bring you back into the Cretaceous time and show how the Mediterranean looked like in those times, seen with the picture which contain the geographical items related to today's situation. So just in those times, we do have the African plate and we do have European, but among them are a lot of places which once used to be the part of the Africa. And they are just because of moving of Africa to the north, moving also. They are collided. There are some kind of convergent boundaries between them. And so this makes the changes in the situation, paleogeographic situation in whole area. So it is dynamically very, very active. So what of our interest is this short situation from Cretaceous up to the recent day, that we do have the Adriatic microplate in the contact with the European plate, and there are two continental plates, two continental plates. So the collision is, and then the one plate went under, so subduction occurred, and we do have, as you can see, some kind of flexing of this Adriatic plate, some kind of fragmentation, and then provoke the changes in the upper Dinaric platform with all these environments which is on it developed, and changes is going to produce. And finally, situation we shall have the Adriatic Sea and this situation. So, just to be aware that due to the subduction of Adria microplate in the Dinaric plate, what is in one way the ground for the Dinaric foreland basin, you do have a lot of changes. So the Paleogene is transformation from something what we know in Cretaceous time or even before as a stable Adriatic carbonate platform. We just left it because there is no more Adriatic carbonate platform. And from this stable item, paleontological in Paleogene, we are moving to very dynamic Dinaric foreland basin. And in Dinaric foreland basin, due to tectonic activities, we have like a wave of migration of deformation. So you will have in some places a deeper basin, in some places you will have something which is shallow water, or even due to this constant tectonical activity, that some of these shallow parts are going to emerge even. So you cannot speak that you have a stable paleogeographical system like having Adriatic platform before. You are just moving all the time and having these changes. And at the same time, when you are thinking about the sediments which are producing, because you have water, you have basin, you have shallow water area, you have to think the organisms, their abundance depend on the climate, of the temperature, the simplest way to say, of the temperature of the seawater. And when we come to the Paleogene, so it means Paleoceneus and even to Oligocene, you have to think of this photo. We show you the following. It was warm. They said about 6 degrees centigrade warmer than today. I'm speaking about the seawater. I'm not speaking at the air temperature. So, but nevertheless, we are facing the trend of cooling, which are going to be on its peak on the Oligocene time, very close to today. And the next thing what you have to think that within this period you have 4 times when the temperature rises extremely for a short period. The first one occurred on the boundary between the Paleoceneus, and it is out of my focus today because we do not have these sediments in dinner. It's recorded or even studied in this way. Okay, recorded yes, but not studied, better to say. Then we come to another period. It is within the Eocene, early Eocene climatic optimum. High temperature. Just for 3 million years this period lasted in geology. You know that 3 million years is nothing. And then we come to 2 periods which are of my interest. It is late luteation and thermal maximum during the luteation time, 30,000 years only lasting. 30,000 years you have to record it and to find in your outcrops in karst region, in shallow water environment sediments, and as well as in the basin. And then the last one, which lasts a little bit longer, 300,000 years, it is a Middle Eocene climatic optimum. So during this period, the temperature rises, even it was warm, to some 27 degrees centigrade, for instance, during these early Eocene climatic optimum. So we have to find them in our sediments. And so for this reason, we pick up several, yeah, that's better. So my area of investigation was in Istria, where we stay close to, so this is a geological map of Istria. In yellow are Paleogene sediments. Mostly they are of a basin character, so it means we are dealing with the flysch, deeper water sediments. And just on the border of this yellow color, you will find even shallow water limestones, carbonates, or the ramp sediments. And these are just pictures to show how the area look like and where we pick up some sediments in Istria. Then I shall move over further on. It means that it is just to go further. Okay. The second stop is not the Dalmatia area. So we are close to the Novigrad on the sea. It is a hinterland of the Zadar area. And so in yellow, the Paleogene basin, how it looks like. And these are in the reddish places where we try to make some sections and to collect the material. And this is how panoramic look like, the Cicola Canyon and the sediments of Paleogene age. Or even when you come to the seaside, you just face the situation which is for you known, how the karstic limestones look like on the seaside, or feel of the fractures, and not easy to even see the strata or to study. And third area of our study, we move to the south. We stay on the island of Hvar, where just in a few places, as you can find the Paleogene sediments. They are karstified highly, as you can see on this, but nevertheless you can see some strata, and then that will help you in one way to do sampling or making a geological column. And on the Pelješac, again, we have just few places where the sediments of Paleogene outcropping, and this is how the surface of the limestones looks like, with a lot of larger bentiforaminifera just see here on them. So first what we have done when we sampling is the age attribution of the sediments, and we use it when you are in the limestones, larger bentiforaminifera. You have to work with the thin section, and for doing the age attribution you need to identify the species, and that is only possible from oriented thin section. So I would have to say that it is not so difficult task, but the main problem is time consuming, because you have to prepare from the limestone oriented thin section, and it is not easy. And the other way how we do the age attribution is when we come to the basin sediments, deeper water sediments. We extracted foraminifera from the marls, because they are mostly this kind of sediments, and then we find the planktonic foraminifera, and we also do the identification. So in both cases we do classification according to the age. For shallow benthic foraminifera we use one classification which was a result of IGCP project in late 19th of last century. It is called shallow benthic zones, which is upgraded, of course, because it was launched in 1998. And for the planktonic foraminifera, we depend on the classification from 2011 by Wade and Hare co-authors. That is the way of age attribution. We started to interpret it the paleo environments, and for this you need to have a very good and as much as you can make a geological section. So you rely on field work. So you have to be very determined when you're on the field to collect the samples, and you can see here that the column, And just on the right side of the column are some numbers. They show you where we pick up the samples. And you can see that the resolution of the sampling is much, much higher when you come to the places where where is the boundary between some lithological changes. Whenever you are in a thick succession of the same lithology, the sampling resolution is not so high. It is just every 10 or it depends meter which you see on the fieldwork. And here is just one of this column from northern Dalmatia Basin, which show us that we have two kind of carbonate production. One related with foraminifera. We called it a biogenetic production and called it the whole succession foraminifera limestones, and the other one where we do have the carbonate production of clastic character. Yes, foraminifera are present, but they are not so important contributor in making this kind of sediment. So it is just some kind of beaches, but not with the foraminifera, a lot of them. So that is what we have. So that is the way how, in fact, you have to work. And the analysis of lithophases is like this. I think that you are aware of what is going on. You have thin section and you have to study them. First of all, you always have the same procedure to interpret the type of sediments using any kind of classification, depends where you are. And after that, that is the simplest way. And then it started not a problem, but the real challenge. You have to say something about the origin, because you have to find out where the sedimentation took place. If it was in the shallow water, if it is in the water below the fair water wave base, or it is related with the storm water base. So how you are going to do this? You have to look at your material, your item in your microphages to see how they look like, the contacts. And then is the third part when micropaleontology start to be very important, because apart from identify the particles, name them, they have to say their origin, the where live of habitats, where they used to live, and how, what they do when something change. They are in charge to interpret this. And this kind of photos will finally say you, okay, your environment where sedimentation took place was a shallow water, but not the simple shallow water. It was like this. It was a kind of ramp, and even in this ramp, you are going to make diversification between the parts of the ramp. So that is the job of sedimentologists and micropaleontologists. So they have to collaborate, and that is how we find out about our Dinaric foreland basin. That, for instance, in the northern part, in Istria, our reconstruction showed this upper part of block diagram with a very simple ramp passing from the inner up to the outer ramp with some kind of slope. While when we are in the northern Dalmatia, we do have a little bit extension of the, for instance, middle part of the ramp. And how we do it, apart from having knowledge, what we occurred, studying them, we also use the recent material or the recent knowledge from the ramp system. And the best where we have to go is to Florida, or the region which is today very, very actual, because you heard every day what is going on there, it is to Abu Dhabi. And this is the best ramp of what you can see and compare with our situation. And just to conclude, after such kind of study, we come out about the shallow water limestones, how thick they are, the ages of them, and in one way, the places where the sedimentation occurred. So we were aware how it looks like, how it changed. But then I didn't say nothing about the temperature. I was just, how to say, paleogeographically describe the Eocene sediments. And then we come to see these two main points. LL10, late lutation, or middle Eocene climatic optimum. So what we use? In shallow water, larger foraminifera. What we can do with them? Somebody would say, if you are looking for the temperature, best way we know from geology courses is to do some kind of isotopic data. But in limestones, with a strong recrystallization, there is no need to do any kind of this investigation, because recrystallization change the primary signals. We do not have anymore. So you depend on a micropaleontologist who is going to say you about the temperature. with the large benthic foraminifera is simple because they host endosymbionts. Endosymbionts are related with the water, which is warm. And so whenever you find large benthic foraminifera, you know that the whole year, no matter if it is a winter or it is a summer, the temperature of water cannot be lower than, for instance, 18 degrees centigrade. So you do know something. So that is how you use. And the other way is showing in this simple graph. You are looking at the number of species and the abundances. So you can see that there are some changes in the number. And that is the way how you can use the large benthic foraminifera. And this is a simple graph showing in dinarids the number of alveolinids, one of the very important large benthic foraminifera, in course during the Eocene, the drop of the number as well as nummulites. But again, you have to be very careful. But you know that in geology you have to be very, very careful when you are making some final conclusion that yes, their number, the diversity is related with the climate condition, but also it's related with them because as all organisms on the earth, they have their own evolution. They are born, they developed, and they are facing their fate that they are going to disappear. So even with this foraminifera, be aware that we have something what we call the global maturity cycle, and this very end of the Eocene time is marked with the declination, yes, which is genetically caused, I would dare to say. And what we can find also in, for instance, what the large benthic foraminifera indicate us that temperature change in the water. You see how they look like, far from being ideal. They don't look like a normal foraminifera because you know they have only one shell. Look at this. Or even they start to be very large. Or even look at the embryonic apparatus. It is always composed of primary chamber, which is just encompassed by the second one. But you can see here that it is not the case in this here or here. And also double. And then what else you can see that they are very, very commonly enveloped with something, or they show the great portion of some kind of changes. Or when we come to the next warming period, we lost this blackish foraminifera. Alveolin is almost they are present, but not in a great number. And we are focused to these hyaline forms, and you can see that we have some deformation in their growth. You see the pattern and then change. Then you can find a lot of this form, which are analysts saying that something is changed on the sea bottom because they are so uncommon. And also, when you start to interpret the number of species, we find out that there are just a few species. We call that we have declination. We had the decrease in a number of different species number, species richness. That is the best way how to say. And another thing appeared, that we have a lot of forms which we know as encrusted foraminifera, and they are just showing here, 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 and here. So the Middle Eocene climatic optimum is also described, or we can describe it with the common occurrence of encrusted foraminifera, which we call the Solenomeris. Yes, and then it is shallow water. What is about deep water? Because you always have to correlate it. It is very difficult to find the continuation sedimentation, but we do some deep water analysis, and we are here in Istria, or we are in Hvar area, and what we can find out that from them we can analyze very well the age, but also we can do some paleotemperature reconstruction, but again we cannot use, in our case, in our study area, we cannot use the isotope analysis, which is the best, because again, our foraminifera, even from the deep water, were recrystallized a lot. But we did some isotopic analysis for the bulk sediments, so we used the whole sediments containing even foraminifera, even marls, which was around them. And what we try to do, what we can do is to recognize the mineralogical and geochemical composition of the marls in order to find out about the weathering on the land, because you always know that there is a shallow water, deep water, and somewhere is a land. In the land, you do have a weathering of the rocks, and it's depend of climate. So it is not the same when it is warm and when it is cold. So we wanted from Flish to find out about the weathering and say something. So this was our aim. We did several columns or section field work on the section, and this is just some of them on your slide to see. And what we find out about them, about the age, we were very short now about the age of the basin sediments because of the plankton foraminifera and also nanoplankton. And I would dare to say that we are now confirming that our sedimentation in the Foreland Basin is not only in deep basin related with the Eocene, but also with the Oligocene. And then we were able to say that about the composition of the marls and find out that, for instance, illite is the most common mineral. When you look what illite means, illite is from the land. So it means it is just transported into your basin, and when find out that illite usually say you that it is immature mineral, so it means that weathering or alteration was not completely. But luckily, we also find kaolin. Kaolin is another mature mineral. So it means that alternation occurred. So it was a war in some periods. So we just compared the quantity of each of them, and our result that we were able to recognize some changes within the marls or within the Flish in this climatic sense. Okay, and what is also very important that we compare it with the other section and look at the section on the world. They are completely, and when you come to our section, because of this, what I say, the continuity is very problematic to find due to tectonics all the time. Our sections are just these small parts, what you see on the very right side of the slide. So what we were able to recognize, that water column was stratified. So it means that you have the upper layer, we call it mixed layer, thermocline, and the deeper water. That is very important. We also find out that the mixed layer was very, very deep. Usually today is some 100 meters, maximum 200 meters. It depends where you are latitudinally speaking, but in those times that it was deeper. How we recognize it? Because of the abundance of some kind of planktonic foraminifera. And we also know that some kind of opportunistic foraminifera start planktonic to be the most common. And then we were able to say something which is important. We have a very high fractionation parameter, and this fractionation parameter said us to the following. You are aware that when you come to the sea bottom, to the basin bottom, that you are in a cold, dark water. That is usually acid water, high pressure, and the solution of carbonates or calcite is very high. But this occurred at 3,000 meter water depth or even below. But our basin, we reconstructed the depth. It's about 1,200 to 1,600 meter depth only. So how we have such a high fragmentation? So we recognize that we have some kind of supralithoclinal area. What does it mean? When the temperature was higher, in those times, a lot of phytoplankton occurred because from the land, with kaolin in it, we know that a lot of material came. So the phytoplankton flourished. And the foraminifera planktonic ate them. So they also flourish. And then they dropped to the sea bottom and they died. And a lot of organic material came to the sea bottom, 1,200 meters. And the presence of them provoked that you have how to say that the environment is not as usual to be. It started to be much more acid, and so you have fragmentation. And this supralysoclinal foramination is very common in modern scene today when we are facing these climatic changes. And also the weathering process said us and this climate that we have transition. So the transition is not so easy to connect with to connect with the exact age of climatic changes, but because they show some lag, we would dare to say, but nevertheless, you can use them to say that something happened, something changed. And then, how it is connected with the Adriatic Sea? Very simple. We pick up just two spots. One is Mljet Lakes. You know, southern Dalmatia, on the island of Mljet, there are several sinkholes, and they are filled with saline water, and this is a lagoon. This is pristine area because there is nothing around. It is only paradise for tourists. You do not have any fish farming, you do not have factories, you have nothing there. So it is more or less pristine area. So in the course of time, we collected samples in this, always the same group with the same way, so scuba diving, and we collected material from the sea bottom from 10 meter down to 36 meter. And we analyzed the samples and find out about the changes in the environment. What we can find, we also were lucky because there is one publication by Slovenians, Katica Dobre is one of the co-authors, so we have something even from ancient time, some information who was living there. And we compare this and find out that in course of time, we do have a lot of changes. We lost diversity. We lost native Adriatic species. But there are foraminifera, a lot of them. But analysis of them show you that prevail the forms which are not of Adriatic origin. They came to us as invasive species. Even before this climatic turbulence time we face it today. So when the Suez Channel was open, we just opened the way to travel from the Red Sea through Mediterranean even to the North Adriatic. And what we do have that these forms are much better adapted to our situation and they now prevail. It is mostly some kind of milioliths and also among which are peneroplates. And also we find out that because of temperature changes, temperature is today we say that it is around 1 to 1.5 degrees centigrade. It changes than it used to be decades before. We do have the expansion of the reef because in the Mljet Lakes there is a reef of Cladocora cespitosa. So that is what we can find out from one region, and these are peneroplates. And just recent study, what we did in Pag Island, you know where it is, show us also differentiation in the composition. We had just one work about the foraminifera from the Pag Island. Again, from the water of around 10 meter water depth. Again, the same way of collecting this by scuba diving. And when we compare 10 years before the data from more or less the same area with today we collected just a few years ago, we find out that we lost a lot of species. Most of them are hyaline species. Most of them are native Adriatic species. And instead of them, we find a lot of milioliths, among which dominated are peneroplates. And peneroplates are not Adriatic foraminifera. It is just important with this Suez Channel opening for the years. And they are prevail. They make more than 40% of all assemblage, and that is a lot. And that is a lot. Losing it, it is a big, big problem. And also we find out that a lot of foraminifera show much more than 10% of them show some kind of a deformation. You will always find that foraminifera are deformed because they are ill like we are. But the quantity of the deformed foraminifera are less than 3%. But when they just surpass 10% in composition, it means that you are in a big problem. And we do have this in Adriatic. If you're asking why there are this nice color I said to you before, we colored it to find out which of them were alive when sampling occurred and which of them already dead. So it means that in just empty shells we were able to find. That is our finding. So what we have learned from the past, look how this foraminifera from Pag Island look like. We find out that there are some similarity when during the Eocene we presume it was warmer, that the number of the foreign species in both cases are higher. And what we can learn for this lesson from the Eocene, we can be at least sure that everything what happened we are going to surpass in one or the other way. Some group of foraminifera are going to be much more abundant, while the other are going to be reduced. They are going to withdraw in maybe some kind of refugee, which we can yet not find where they are. But always foraminifera seems to be resilient enough to surpass the water temperature, but with the changes in composition. One group completely declined, the other group took their position and even do some adaptation to new environment. So what we can use as conclusion, that is the conclusion, that we learn from past a lot of things, that we even use something from the past to see what is going on in the future, or even not to say that changing are not going to be in the Adriatic Sea. They are going to be, because the temperature of the Adriatic Sea is higher and higher. But foraminifera are going to stay there. They are not going to be on the same, because native species are not well, not plastified in, how to say, they not show this plasticity to adapt themselves to new situation, but nevertheless the new form are going to replace them. And what I plan, or my group is planning to do, is to continue to work with the recent foraminifera, and that is project which lasts for years with the Katica Drobne. It's about Sphaerogypsina, one cosmopolite foraminifera present in the Adriatic Sea, not in a great number, but nevertheless present, and also continue to work in this micropaleontological, sedimentological work with the Eocene sediments from the Naridic foreland basin. Yes. So this is a literature which I use to do, and this is literature which is a result, because a great portion of of this presentation was a part of the project which was going on in our department related with the Croatian Scientific Foundation. It is just a paper publishing from this project that's still going on, and I would like to thank you. Oh, yeah, what is going on with this stone balance? Disappeared. Okay. To thank you for today, for being patient with me, to stay 60 minutes almost. Yes, and I hope that in the future you will see some beauty in foraminifera and do some work with them, because they are amazing organisms, I would dare to say, and their potential is very, very high. So thank you again, thank you for being here, to have a patient, thank you to your students, professors, and for all, I have to say thank to Slovenian Academy of Science and my mentor, because I'm one of the lucky person, being old and still having your mentor means a lot. So thank you.
Vlasta, najlepša hvala. Nekdo te vprašal, lahko v slovenščini, lahko v angleščini, lahko v hrvaščini, če želite.
I'm sure the students do not have it, because it is a normal, I used to be teacher and you teach, and I know that after 60 minutes of some lecturing, you do not have a question. But there is a question. Adrian is here.
Thanks, Vlasta. A question about, like, in modern environments, one of the most prominent evidence of global change and heating and changes in sea temperature is coral bleaching.
Yes.
And coral bleaching is actually losing of symbionts in coral. In corals. Is there any evidence in modern or ancient forams that they would lose their symbionts due to?
Yes, we call it white plaque, but it is registered only in the foraminifera of hyalinths, so Amphistagina. And Amphistagina is one of the foraminifera which was not native in Adriatic Sea, so I cannot see it yet here, but what we know that Vlaste Ćosović is already entered into the Adriatic Sea and occupied the up to Montenegro coast. So we know that in some 5-6 years it's going to occupy the complete eastern Adriatic coast, and then we can look of bleaching on them. Because you need to have hardened foraminifera. We now have only these porcelanos, these penadophytes, and the bleaching is not a problem because the endosymbionts are, it is differentiation in the shell structure, so they can avoid, and also the penadophytes are usually related with the seaweeds, so they are already on a dark ground line. So yes, they are. White crack is called these effects. It is registered in Florida, even on the Israeli, of course. Yes. Then, yeah. So that is, yeah. But we are not looking forward to have this Vlaste Ćosović, because when we shall have Vlaste Ćosović, we shall have just 2 or 3 species only. A lot of them, but not other. Especially our forms, like not Elphidium, but for instance Rosalina. No, I'm not going to follow up. Not to show that I know some forms.
Any other question?
But not with aware of climatic changes. We should survive. Because when I didn't say, for instance, we did this isotopic analysis of late flotation thermal maximum in Istria material, and you find out the temperature was around of the water. I always speaking about the water, surface water is between 25 and 27 degrees centigrade. But today is, the average temperature of the ocean, 13 degrees centigrade. Especially not in Adriatic, which is the coldest part of the Mediterranean.
In summer you can go up to 30 warm for a surface water.
Yeah.
Especially
Meaning this
in northern Adriatic.
Yeah, I do some work with Professor Petra. I am doing Slovenia offshore. Yeah, I'm doing Slovenia offshore. Close to this thermal and springs, Isola, Ronek, and you know it better. And it is interesting to see the combination of association of foraminifera close to what we think is a thermal spring and when it is a cold spring. So there are some assemblages and they are not so similar. There are some similarity, but mostly the differentiation. But the problem is that foraminifera survive temperature.
Another maybe trivial question. Where are forams in trophical cycles? Who is eating them?
Nobody. In fact, nobody them because just dentalium. Only the scaphopods, the dentalium eat them by purpose. The other, they are just, those who are floating, they can be taken by the organisms who are just like whales doing it. But they are going to expel it out without any changes. There is one story about the foraminifera, why they are not so, lot of bones, just a small portion of cytoplasm to eat. And also the foraminifera, when they are alive, they are just wrapped in some kind of ectoplasm, which is not suitable to eat. It is like mucus. Look like mucus.
So those which are found broken are basically just a coincidence of eating something else.
Yeah. There are some, we find some borings inside, but we think that this is like entobia, just on already dead, trying to some place where it's going to sleep or doing something. Especially with this, and also microborings which are related with bacteria. Also, when they are dead, lying on the sea bottom, already bacteria, microborings can be just attacked. But no, by purpose, no, except then scaphopods. They are not eatable. A lot of bones, as I said. You see, for instance, there is one paper, but very old and not fashionable, but people are looking. Professor Pavlec from Ljubljana, he in Creta, in US sediment of Creta, found out the one foraminifera named Nomolites genus, which is up to 20 centimeter when you look at the inside it is a lot of walls, septal and everything, and the foraminifera live just in a final portion. So it is just a small amount of material what you would eat. That is logical. Nobody is interesting to have a look. Yeah.
Kako promjena pH vakuuma utječe na formiranje nekih usluga?
Pa one su uvijek u balansu sa pH-om, znači s obzirom da je... Hvala na ovome. When they are, when you are producing the skeleton, you are always in some kind of balance with pH and also pH, and also you have to think that you are not directly, your skeleton is not directly exposed to the water, because it is just wrapped in this small kind of sac, which is organic. But usually calcite is a problem that when there is no this sac which is related to foraminifera is life, then you face a problem with the pH. And so if it is acid, you are not going to stay. But acidification per se doesn't influence in the number of species which are producing today. No, because they will find places upper water bottom is usually basic. So that is that they live the occupied. No matter if this acidification is earlier. So happening. So they are not so how to say, for them there is no great importance while they are alive. But when they die, then the destiny of the shell is a problem with the acidification, because they are going to be strong, dissoluted, whatever you want to say.
May I ask a question about the foreland system?
Foreland.
I found it very interesting your reconstruction with isolated platforms.
Yes.
So how many are they? Do you have do you have I don't know, distribution? Paleogeography of this, because we are used to this platform.
That is the big difference is how you have to deal with the Adriatic Poland basin and the Adriatic Cantonal platform. Because in the Adriatic you have one platform and you are just changing shallow and deeper or whatever, but platforms. But here we find out that this is a temporal ramps. So it's depend where you are, and they, due to tectonic adjust, because it is a shallow water, you can have this uplift of immersion. But how many they have, maybe you will find in Katica papers, because Katica interpreted it as the biozones. She found 4 biozones, and that is the way how they progress due to this, as I said, the formation is like wave of migration of this part. So Katica has a biozones there. She was not interpreted in dynamic way, how we do now, because science change and the approach change, but that is what she called it. She said that the transgression started from the northwest, going to the south in several waves, and then you have in this part. So that is. But in northern Dalmatia, we were able to recognize them several because we will have picked with moonlights, picked with the plastics, picked with this. So it was a form which we recognized in northern Dalmatia.
Good, thank you. And all this is published in your 18th paper. Okay. Any other questions? So I think. Thank you very much again. Najljepša hvala.
Najljepša hvala svima i zaista što ste bili. I ja ću ponoviti, mada to može zvučiti sa kažem Hrvatske, ako me razumijete, onako kao floskula, ali stvarno mi je bila čast ne samo biti danas pred vama, nego uopće, ne znam kako bi vam to rekla, da doživite to što se meni dogodilo. Hvala vam što ste mi nekako bili tu i lijepo bili sa mnom. Baš vam hvala od srca.